the integral of sine x dx is equal to negative cosine x plus constant of integration. Now I expect you to ask, what if I have something like this? What if we have the integral of sine of ax dx? What is this integral? Basically, we can use the method of substitution and calculate this integral. If this is your u, so let u be equals to ax, then du is equal to a dx. Or basically, dx can be written as du divided by a. So your integral in terms can be written as sine of u and du divided by a, and a is just a number. It's just a coefficient. Remember that if you have a coefficient, you can write it in front of your integral. 1 over a integral of sine u du. But as long as you have sine u inside the integral, this becomes negative cosine u. So you have 1 over a negative cosine u plus constant of integration. But what is u? U is equal to ax. So this guy can be written as negative 1 over a cosine of ax plus constant of integration. So this gives us a general approach. Whenever we see the integral of sine ax, it is negative 1 over a cosine ax. So sometimes it's when you see this with repetition, you memorize this. The same for the integral of cosine. If you have the integral of cosine x dx, it is basically sine x plus constant of integration. Now I expect you to ask, what if we have the integral of cosine of ax dx? What is this integral? So in that case, if you take ax to be your u, du is a dx, or dx can be written as du divided by a. So this can be written as the integral of cosine u du over a, or 1 over a integral of cosine u du, or 1 over a sine u. But in terms wherever you see a, u, you're going to write down ax and then the constant of integration. So basically the substitution method helps us to calculate these a little bit easier. Now, what if we are interested in calculating the integral of, for example, secant tangent? How do you calculate the integral of secant of x times tangent of x dx? What is this integral, right? To calculate this integral, let us break secant and tangent a little bit. This is the integral of secant, which is defined as 1 over cosine of x, and tangent is sine x divided by cosine of x dx. Or in simpler form, this is the integral of sine x dx divided by cosine squared of x. So I expect you to ask, what if we use a substitution here? Okay, let's try. Let us take u to be cosine x, du is negative sine x dx. Do we have sine x dx? Yes, sine x dx is on top here. So you just need to multiply it by a negative sign and another negative sign. Negative and negative, they cancel out each other. You end up with a negative sine x dx, which is your du. So this guy also can be written as minus integral du divided by u squared, or negative integral u to power negative 2 du, which in turns is negative. You have the negative sign, and u to power negative 2. If you add 1, you get negative 1 back. U to power negative 1 plus constant of integration. Negative and negative, they get canceled out. So you end up with u to power negative 1 plus c, or 1 divided by u plus c. But what is u? U is cosine x. This is 1 divided by cosine x plus c. But by definition, 1 divided by cosine x is secant x plus constant of integration. So substitution helps us to calculate the integral of secant x, tangent x a little bit easier. So students tend to memorize these formulas. You can memorize this formula, or you can basically use substitution to see the calculation behind this and get to the final result here. Well, you could take the derivative of secant x and show that the derivative of secant is equal to secant tangent to verify your formula as well.